MAC address section of the network fundamentals. This is just going to be a high level overview of what a MAC address is. So as we can see here, the MAC address is also known as the media access control. The MAC address is a physical address. It's assigned to a network adapter by the actual vendor itself, and it's designed to be completely unique. No two devices in the world should have the same MAC address. You can see here that the format of the MAC address is in hexadecimal. So as you can see here, so hexadecimal goes from 0 to 9 and A to F. If you're unsure about hexadecimal, we will cover that in a later video. There's a few names that MAC address is known by. As you see, it's known by a burned-in address, a hardware address, or a physical address. The MAC address is 48 bits long and it's split into two halves. The first half, in other words, the first 24 bits, is the OUI, and that is unique to the actual vendor. Now, some vendors, for argument's sake, Cisco, Juniper, and some other big ones, have multiple OUIs for them. The second half of the adapter is the unique ID of the actual NIC card or the wireless adapter or the cellular adapter, say in your phone, for argument's sake. Each half can hold up to 16 million unique addresses. In fact, if I believe rightly, 16,700,000 or so. That also means that there's 16,700,000 vendor addresses as well, which is quite a lot. Okay, let's have a look at the next slide and see where we're up to on that. Okay, so as we can see here, this is just a brief overview of the header, how it's looking. We'll go into this in more detail further on when we move into the next section. You can check the MAC address vendor at loads of online tools. I personally use macvendors.com. If you pop the MAC address of your network adapter in there, it will tell you the ultimate name of the company that actually made it. So for argument's sake, this is from a Dell laptop, but the actual person or company who made the actual adapter, as we see, is Wistron. I've never heard of them, but you know that doesn't mean that they're not exceptionally big, especially if they're making network adapters for the likes of Dell. Okay, so as the MAC address is a physical address, protocols have been put into place to work with these. Switching uses these addresses, and we will see later in the courses that every frame that is sent in the network, whether it's either going out on the internet or whether it's in the private LAN, uses a MAC address as part of each packet. Layer 2 on the OSI model uses MAC addresses as its primary address space, and this PDU is known as a frame. What we're going to do, we're going to show a couple of examples below of how you can actually find the MAC address. Okay, so if you're in a Windows machine and you type ipconfig/all on your command prompt, you'll see here is the MAC address right here. So the MAC address of my PC is C3, 7C, 3F, BB, EF23. That's it. Every single adapter has a MAC address on it. If you're on a Linux machine, you would run the following command, an ifconfig. Now on ifconfig, you can see that there is a MAC address right here. Let me get that up under Ether, which is there and there. You notice how it is split. It's still 12 bytes long, and it's split into 6 there for the OUI and 6 there for the unique identifier. So moving on from the Linux terminal, if you now say going on to a Cisco device, and we'd run the Cisco by running a show interface and whatever the interface name is. In this case, it's show interface Ethernet 00, which happened to have been what I was actually using. You'll see the address is here as well under the hardware address. As you can see, it's right there. You'll also notice the BIA, which is the burned in address, which is another name for the MAC address, which is there, and it's identical to the actual hardware address. Now, if we have a look on a Juniper device now, a Juniper device is very much the same thing, show interface, and in this case it's show interface Giga Ethernet 000. And as you can see here, here's the hardware address right there of the actual device. So again, just to show that every single device that's capable of transmitting packets has a network address. Let's clear that off the screen. Okay, what I've got for you now is a Wireshark capture. Now, if you've never used Wireshark before, it's free software. It will inspect any packet that is transversing over any interface that you select, and if you're using virtualization like EVE-NG, GNS3, you can run it on that as well, and it will basically show everything, every single packet, no matter what it is. So on my EVE-NG, I just had one of my routers pinging out to Google, and as you can see, we have these packets showing here. So as you can see, we've got ICMPs, which are pings. These are all pings going out. As we can see, it's we've got one of the packets opened here. So it's an Ethernet packet. Part of it is the Ethernet. You notice it has the source and destination MAC addresses, which are right here and here. So the source is the network adapter on the PC the router I was using rather on, and the destination is the next hop. So the destination would be my router's gateway, so it could actually break out to the internet. Every single packet, regardless what it is made up of layer 1, layer 2. If it's going at working on IPs, layer 3, layer 4, etc. We'll be doing a lot with MAC addresses when we go into things like switching, and when we go into playing around with VLANs and stuff like that, where we're going through the ARP tables, the MAC address tables. This is just a brief overview of MAC addresses, but don't worry, we will go very much more into depth regarding it. I hope you've enjoyed this little tidbit, and hopefully I'll see you in the next lesson. Okay, so let's have a look now at the collision domains. As we can see, we have a hub right here, and we have